Well, hi, good morning, and thank you for taking time out of your day to come and see what I'm doing with this radio. Today is September 25th. Another sunny day, 22 degrees. You just couldn't ask for better weather. And that's why I'm down here in my windowless shop down here this morning. So, okay, what are we going to do today? So today I think I'd like to focus on this capacitor and maybe this one too, these two big guys. This looks like it's a replacement. It's also hanging on wires, although not as floppy as another. This one could be a replacement also, and maybe part of the giveaway is the type of wire covering that was used here. It's the same kind of wire covering. Okay, step one would be to figure out what this capacitor is doing. Where is it located? It's located, let's see if we can find a landmark I can hunt down on the schematic. Let's see. So it's going to, look at this, the speaker wire when it flexes, it's moving all this stuff in here. So these are cloth covered wires, so they can take the movement. If these were the same as this one, there'd be no insulation left at all. So even though these cloth covered wires are probably older or of an older style than the plastic covered wires, they stand up better over time. So one lead goes down here, that's the rectifier tube, I'm pretty sure, and the other lead is going to the output tube terminal, right where one of these wires that's heading up to the speaker is going. Can't tell easily what wire's what on the speaker, but we can figure out what pin this is, and then we can look on the schematic and sort things out from there. Could also just look on that parts layout diagram. So 8, 7, 6, 5. So this guy is on pin number 5 of the output tube. Okay, let's take a look and see what we can figure out here. Pin 5 of the output tube. Okay, pin 5 of the output tube. So this is a slightly different version. It's the same schematic, it's just been photocopied differently than the earlier one. Pin, oh, I thought these were numbered. Apparently not. Okay, well, they're going to be, let's go to that other diagram. Let's go back here, and we'll go to this diagram here, and we will see this is the 5W4 rectifier, this is the 6F6 output tube. Pin number 5 would be, this is looking from the bottom, so we count this way. 1, 2, 3, 4, 5. This would be the capacitor here. 0.01. 0.01. Well, this shows it tying to the same terminal here. Okay, and what exactly is, there's a resistor here. Why don't you show what this strange piece across it here? Is that supposed to be a terminal strip? I don't know. Well, a 0.01 is a far cry. Well, it's not a far cry. It's 1/10 of what's in there. 0.1. And the connection isn't to here. So have I got the wrong one here? What's this one doing? This one's coming over here. 0.05. Where is there a 0.1? Where is there a 0.1 capacitor? 0.5. There's a 0.1. Notice they don't show these to be different sizes at all. 0.1's a big capacitor though. So I have a 0.1 here. Maybe I read the value wrong on the capacitor. There's no 0.1 over here. And I've got one going from here. Let's see, is there, maybe let's just trace this. Let's trace this. I'm on the other side of a resistor now, so it doesn't make a lot of sense. It's pretty interesting how they show on this. A 0.1. Just looking everywhere just to make sure that it isn't hidden up here somewhere. I like this diagram. This is a really nice diagram. There's a 0.1. Okay, so it's coming. It's on the ground connection. And the other lead. It's on pin 8 of which tube is this? This is the it's written in here somewhere. 6L7. 6L7. Well, that's not a terribly common tube, I don't think. So, wait a minute, there's another 0.1 right here. But there's nothing down this end. What am have I got something totally backwards here? We should try to find these 0.1s. So on this diagram, they are grounded to the ground terminal here. There's like two capacitors coming off of this ground terminal that are 0.1s. Okay, let's go take a look. This radio is offering up lots of interesting challenges. So these would be the 0.1s, and they are. This is a 0.1. And this is going to be a 0.1 also. And right onto the ground terminal. Just what the doctor ordered. So my good guess is these are the original 0.1s. Now that's fairly small for a 0.1, because look at the size of this one. That sort of gives once again the hint that these are electrolytic, but they aren't. Well, that's a lot of big capacitor, a lot of 0.1s. That's for sure. 4 of them. But we still don't know how this guy fits into the picture. So down here, I can see a capacitor there. This may or may not be a capacitor here. And this one. And that's it. So we'll double check the connection here. Pin number 8765. There's no question it's on pin 5. And you know what? There's another one on pin 5. This one right here. It's hooked up to pin 5 also. Between pin 5 and pin 6. Okay, look between 5 and 6 on the output tube. Pins 5 and 6 on the output tube, and find another capacitor. 5 and 6 on the output tube. Okay, output tube is down this way. 5 and 6. 1, 2, 3, 4, 5 and 6. There it is, right there. 0.01. And now there's another capacitor attached right here. A great big 0.1. And it's not going here, it's going, well, where is it going exactly? I'll just look back right now and just take a look here. This is on the rectifier tube. It's going to an unused pin. Or it's making a connection with a couple wires. One of them takes a long run through the radio. Oh my gosh. Okay. So did I just see? I just see the other end of this mystery capacitor is tied to, I didn't count the pin number, I got involved with the wire, did I? The pin is, looks like pin 7 to me. Pin 7. This open pin rating. No. Here. And there's the long wire. They claim it's blue, but it's way wide. Tone control in mounted right out front of the radio. What's going on here? What have they done? There's a capacitor running from this pin, a big capacitor running from here over to here. This doesn't make much sense to me at all. So this is the rectifier tube, but it's an unused pin, so it's nothing to do with the rectifier, it's just a connection point. So this is really a connection point here for this capacitor, 0.05. Let's follow this wire again. Did I get it wrong? No, right to the tone control. And what's happening over here now that my eye has made it this far? Braided flexible leads. And I don't know what's going on here. Okay, we're not going to worry about it for now. Something interesting over there. Well, what do you do when you find a capacitor that doesn't seem like it should be there? And what's this thing? Coming from the transformer. What's going on here? I got no answer to that question. This is a weird looking thing here. Doesn't seem to be anywhere in particular. Looks like a loop. And then is this supposed to represent tape? Or just the wire being twisted back? Is it a test point of some sort? I can't imagine that. Just laying loose in the bottom of the radio? Haven't seen anything like that in this radio or any other, really. What an oddball situation again. So let's look on the schematic. So we're looking at pin number 5, which is the grid over here. The grid of the output tube has that great big capacitor on it, working its way back from the tone control. See this one, here's the plate. This is the output of the output tube here. And part of the output is spent on this capacitor and the tone control. So they're throwing away some of the output, the treble part of the output, if you adjust the tone. That makes sense. That's commonly how it's done. It can be done on the grid side or done on the plate side. Back to the grid here. Oh, I just noticed there's no. This is a spare pin, spare terminal here. So why would you do that? Why would you put a big capacitor back to the grid here on the tone control? Have a tremendous effect on the tone, wouldn't it? That's like feedback too. If this capacitor is there, if this one is there, then you'd be hooking the plate output to the grid through a 0.1 capacitor. It can't be the case. This just can't be the case. My wild guess is this capacitor is not there. And an alternative to a small amount of capacitance back to the plate is a big capacitance back to the grid. That doesn't, I don't believe it for a minute. But how will you explain this stuff? Okay, let's go back and look. Until I feel certain, I don't want to do anything. So let's go back. We'll look again. We'll try to find this guy. C34 off of the same place. Going back to the plate. Off, yeah, right. Sound a little upset there, don't I? So, if this guy come over here, maybe I misinterpreted. No, it's tied to this terminal of nothing. And then, for sure, this is the tone control. Let's follow it all the way up here. Goes all the way to this location. Oh my gosh, look at this. There's a capacitor sitting here. Capacitor could sit here, it could sit at the other end of the wire doing the same thing. Goes down to the chassis. What's this little piece? Oh, well, I don't know. It looks like a shielded wire with the center grounded and the shield brought out. What? Come on. Okay. Too many weirdnesses here at once. Let's stick with one weirdness. It's probably all misobservation. It's probably what I'm suffering from here. So is there another capacitor? It's supposed to be down in this area. There's this one. But this one, I gotta look at the diagram again. Didn't I print this diagram? Oh my gosh, I did print it. Okay, that's easier now. Well, that's going to be a little easier. So we'll tip it like this. We won't. We'll tip it like this. And here we are. So that capacitor that runs between the pin on this tube with the wire coming all the way from up here. That's here. Not here. Something is really not adding up at all at this point. So I think we concluded this was the volume control up here. I'm pretty sure it's the right conclusion. It'll say right here. It will say, oh, it does not. Volume control. Oh. One control, two controls, three controls, and a band switch. 1, 2, 3, and a band switch. Well, look at that band switch. This radio just keeps on giving. So this is a little surprising. Usually the switch is, right off the shaft with rotating wafers or a slider rotating against wafers. This one comes down, has a mechanical interlock into here, and the switching is occurring down under here. There's the wafer switches right there. The two wafer switches, and then there's a linkage system to rotate the. It's very painful. I need more coffee for sure. Okay, didn't see that. Haven't seen that though till just now. Not an expected thing, but see what they're doing is they're shortening down the leads. They're making the radio's design more and more efficient, probably easier to build, and probably less trouble building it. That'd be my guess. That's what they're trying to do, I'm sure. Okay, we've really wandered off now. Back to where we were. What to do about this? Why is it even here? Did I get the other end of it misinterpreted? I don't think so. It's quite clearly tied to there. There is 8, 7, 6, 5. Count the other way. 1, 2, 3, 4, 5. It's 5 no matter which way you count it. Oh my gosh. Sorry about that. So there is no capacitor shown here. This guy's not shown. This one up here is shown here, along with the resistor connection and the wire coming back. Wait a minute now. Yeah, this wire, this wire that I'm following doesn't go up there. It goes here. Goes here. They're twisted around each other. Yeah, you know what? I was following the wrong wire because they wrap around each other under here, and I just went from one to the other. Okay, so the wire from down there comes to here, just as shown on here. What's this capacitor doing? Why would somebody do that? Like, what would even prompt it? Some kind of tone adjustment, some kind of tone thing. Misreading of the schematic, an entire misreading of the schematic. Like a complete mistake. It should not be there at all. Yet the radio's working. You know, if the radio wasn't working, this would be an aha moment. Which you don't think somebody else would put a part in, and then the radio would stop working, and then they just leave it. That's not going to happen. So what can I do about this? Well, I can have the set operating. I can cut this out. Let's see what happens. What's the difference? I wish I had a better grip on what's going on here. Because you know, what I'm concerned about is just simply a gap in my understanding of things, or some error I'm making. And so I'm going to compound it. If I take action based on erroneous thoughts, it's just going to generate more errors. Yeah, that's why truth is so important to us. So this capacitor, which is shown there, which is different in position from here. Wait a second. They're showing this one here. One here, one here. One there, one there. One here. None there. This one's missing. This one runs from the pin in question and comes up to the comes right here. Comes right, there's nothing wrong. Comes to the same terminal that this capacitor is connected to. Pin number, I'm having trouble seeing this, 1, 2, 3, I think. Is that right? Oh, just got a wire in the way here. Hey, wait a minute, this isn't the same either. Showing the pins on the diagram. The key on here is showing this way. look at the tube. That's dirt I'm seeing. That's not. Oh my gosh. Jeepers creepers. When I looked away for a moment, I forgot what I was doing. Can you believe it? Well, it also goes to a wire out to the speaker. Is that what happens on here? We have a wire right out to the speaker. So capacitor's in the right place, but it's the wrong size by a long shot, and they're replacing one that was down here, which is why he didn't bother putting it down here. It's too easier to stick it on top. Why a 0.1 in a tone control? Is it different on the schematic? Okay, let's look at the schematic now again. So this is the one. There's a lot of malarkey here because I think I miscounted the pin numbers here or did something, got me way off. So here it is. This is the guy, 0.05, and instead it's got a 0.1, which is like 20 times bigger. That's surprising. This is not a critical capacitor, but you think putting in too big a one would cause too big of a treble cut, and it would muffle this radio badly. Of course, you can just adjust the tone, and this is 100,000 ohms here. You could just adjust the tone, and it would be like a tone control that's just too sensitive. Advance the control at all, and the tone, the treble disappears. We got to try this. We got to operate the radio and see what's going on with the tone control. And maybe a guy made a decision to put in a bigger capacitor here. Did I say 20 times the size? It's not 20 times the size. It's double. It's only double. It's only double. It's not that much. It's not that much. So probably this is what he had in his junk box or available, and he stuck it in. And he probably said to himself, if it changes the dynamic of the radio, you just tone control your way out of it. Kind of like the volume control solves all problems, because you just turn it up louder. Okay, that's an awful lot of effort for very, very little. For just discovering all my mistakes is really what I've been doing this morning. Okay, well, I could put a 0.05 back in there. Maybe his thinking was I'll put this old 0.1 and it's weak and it'll be like a 0.05. Okay, I think I got my head all cleared up on this. Let's check that tone control. I gotta play the radio at this point anyway before I change this. Okay. Yeah, wild goose chases do occur. And I did say something about you're making a mistake, you're just going to compound it as you move forward. So, okay, can we operate this radio? Yes, we can. Who said that? I said that. I'm in charge here. That's a scary thought. Okay. So, I have the speakers connected. Volume is turned down. Hey, let's throw. We'll try cleaning this volume control at the same time. This time around. Ooh, it doesn't look so easy. Looking for a place to spray the cleaner in. Oh, here's a spot in the back. That's going to do it. Okay. There we go. I'm going to throw in WD-40 now. So some of you might go, no, don't do that. But this control feels like it needs some lubrication inside it too, believe it or not. So we should do this with a set operator. Okay, volume's down a bit. Tone control. What is this? What is this last control? Anyway. Speech, music, and power switch. Speech, music, and power switch. Speech, music. Sounds like a tone adjustment of some sort. Is there anything hooked up to it? Yeah. Okay, a little bit of a mystery still. This is just what is going on. Here we go. Let's stick some kind of antenna on it so we hear something. I'm going to go on the inside here where it's easier to clip. Good show. Something a little amiss with the tuning here. It's not doing anything. Skipping in there. There we go. Okay, a little more volume. It's actually doesn't sound dirty, but it feels bad. Smooth as can be now. Doesn't skip at the bottom anymore. Okay, just 1 second. I don't want to blow your ears off, but I gotta go all the way here. Okay, power back on. Okay, what does this tone control do? To be doing almost opposite to what I said. Seems pretty good. So that doesn't sound muffled to me. I got it on maximum treble. But a lot of the action is right at the end of the control. The last quarter of the control. And the way I'm turning it, I'm increasing the grounding. So that makes sense. So this way I restrict how much is being fed through the capacitor, how much of the sound is going through the capacitor, and this way more and more of it goes. Now, is that over muffled? Is that stupidly muffled? Bearing in mind the speaker's just sitting on my bench there, it's not in its cabinet. Well, it doesn't seem to be limiting the treble, but it does seem to be compressing the range of the tone control. And it probably is a little over muffled at the end. A very subjective thing. So what happens if that guy's leaking? Well, he's right on the plate circuit. So he's got a big voltage across it. How big? People want to know. How big is your voltage? I may have this backwards, but it doesn't matter. 170 volts across that guy. It's on the plate circuit. Fairly low impedance circuit. A little leak in that capacitor is probably not going to have much effect at all. Let me nip it out of there and see what happens. You know, I like the idea, but I'm scared to do it. What's the worst thing that could happen? The radio goes crazy. It loses. It's right now. It's some kind of oscillations being prevented by this. We don't know that. So with this, cutter's at the ready. What's the worst thing that can happen? Terrific embarrassment. Okay, now, no tone action. No tone action at all. We can put in a, oh, I don't know. See, I don't know what's inside this box. Yikes, until I look inside. I can't put this in where there's 170 volts. There are probably 600 volt capacitors inside there. I was going to hook up the decade box and mess around, look for the right size. But you know, it's written on the schematic. 0.05 is the right size. Okay, we got this guy part way out after all that. Made in the USA, Bayonne, New Jersey. Back in the day when the industrial center of North America was basically the American, I don't know what you would call that, the Great Lakes region, and over into New England, over in that area, all through the river system, the Mississippi River system. A great and wonderful Mississippi River system, which the United States owes an awful lot to the Mississippi River system and its huge tributaries. Not a lot of countries have that kind of river system. Few in fact, have a very helpful navigable river system for industrial purposes. Okay, 50 volts on the big one. Show straight up. 150. Part way. So testing in comparison to other capacitors, this one's not as bad as some of the others. And why? This is almost certainly a replacement. I mean, I think we can be 99% sure. It's not as old as the others. Why would the guy replace that? Because the other one had lost its capacitance. Oh, coffee time. The other one had lost its capacitance and the tone control didn't work, and you can tell. You can tell that problem exists because the tone control is not functioning. So, okay, I must go for coffee now. I'm going to stick a 0.05 in there. We'll check the tone control afterwards. Partway through installing the new one, when it suddenly dawns on me I should deal with this one. It's on the same terminal. So let's figure out what's happening with this guy here. What is he about? So that's this one. Here, number C looks like 31, C31.01, no, C33.005, wrong one I was looking at, C33. Let's look on the schematic. So there it is there, C33.05, sitting right there, and that's the other one I'm just putting in. Okay, C33. There it is there, C33.05. So this is right across the output of the tube, and the purpose of this one, it's probably got more than one purpose, but one of the purposes is to sort of quell any harmonics that are coming through the audio system here. These radios have a fair bit of harmonic distortion, and the result of that is you would not like the sound. Basically, I guess that's the best way to put it. So throw a capacitor in here. It won't affect the audio that you want to hear, just the highest, very, very highest. Yeah, okay, anyway, enough muttering about it. 0.005. We might as well replace that right now too. Oh, what's this? Oh, this is the one I am replacing right now. That's the tone control right there. Okay, got it. 0.005. Okay. Okay, got a replacement ready. Let's cut it out. We'll give it a test. So probably if this capacitor wasn't doing its job, you probably wouldn't really notice. I don't think I want to operate the set without it though to find out. .005. Westinghouse. Okay, over you go. What are you good for, capacitor? You're probably not good for much at this point. Let's see. Well, I don't think there's much DC across this. Okay, 50 volts. What do? Close and not opening at all. So all of these capacitors have shown up to be pretty bad. Probably the performance of the radio is being dragged down in various ways, but not so much that you couldn't compensate with the volume control or maybe the tone control too. Okay, so I'm going to put this guy in and the other guy, and then we're going to run the set, make sure it still works. Okay, I think we're ready for another test here. So plug them in, put the antenna back on. Okay, volume is down. Watching the dim bulbs. So they hardly reacted there. Does that mean those heaters are still warm? I doubt it. There we go. Okay, so we're going to give it the full treatment here. 112 volts. Very good. Now, something I think might be of interest is what's happening to this resistor I put in. Is it overheating? It takes a little while to heat up, but if it's going to overheat, you could probably tell already. So the red you're seeing, I can cover the, well, my hand is red. So on this screen, there's a little plus sign right in the middle, which you probably can't see. It's very hard for me to get this on video properly. Right dead center is a plus sign. Anything under that plus sign, temperature is reported here. So if I move things, put the plus sign right on top of that resistor, close to 50 here. 50 degrees C. The other one beside it, 33. So anything else in here that's cooking up. So we got something right there. That's 26. Again, I know you really can't see this. Quite a few things in here that are warm. See the resistor back here. too sensitive. Let's change the sensitivity here. Okay. And you're going to see the objects a little more clearly and go even higher here. 40. Okay, so things have to be close to 40 degrees to show up as red on here. You see the two resistors here and here. And now, is there anything else showing up red? Nothing. Yeah, this. Another resistor right here. And the temperature of that one is, that's about 40. This one here is also 40, and then the one I put in, 60. It's up to 60 now. '60's getting pretty warm. You can even see a bit of heat. Oh, it's probably a reflective heat in here, but it's probably a reflection. Or it's being heated up by the adjacent resistor. So we'll keep an eye on this. It's probably okay. It's in a safe position. It gets a little hot. I don't think it's going to matter too much. It's not close to anything. Okay, tone control. Tone control. Wow, talking about muffling. Well, the whole control has a range now. Can't hear anything there. That's a good sign. Probably in this setting, all the trouble that's available is getting through. It's what it sounds like. And it's not all bundled up at the far end anymore. But boy, does it ever go down. Okay, very good. That's it for today. Those two, just two capacitors I did. Okay, so we've left this big one, but that's it for today. Because it's just too nice a day. What am I doing in here once again? I'm heading outside. So thanks a lot for watching. And we just keep plodding along here. And good. See you later.